Hey everyone, in this problem we are looking for the wavelength of a laser light based on several other variables if the laser has been sent through some slits. And we want to find a relationship between the distance between the bright fringes and that wavelength. So we can use the equation. We can start by using the equation that tells us that the location of a bright fringe at some fringe number m is equal to the wavelength of the laser light multiplied by the distance between the slits and the screen multiplied by the fringe number divided by the slit separation d. For our first step, let's come up with a formula for the distance between two of those bright fringes. So delta y bright, and that should be equal to the formula for the location of the bright fringe at some m value m plus 1 minus the location of another fringe m. So the expression I've written here represents the distance between two consecutive bright fringes. Putting these values into our earlier equation, that is the lambda, for m plus 1, that is the lambda L multiplied by m plus 1 divided by d minus lambda L m over d. Let's use the distributive property on the m plus 1 parentheses. So that's lambda L m over d plus lambda L then times the 1, because we're distributing the lambda L to the m and then to the 1. So lambda L times 1 is just lambda L over d, and then just subtracting this last term. So lambda L m over d, and this term, this third term, is the same as the first term, and since they're being subtracted, they just cancel right out. So we're left with the final expression being lambda L divided by d. And that's equal to the distance between two fringes. Since we're trying to solve for the wavelength, let's algebraically solve this expression for lambda by multiplying both sides of the equation by d and dividing both sides of the equation by L. So lambda is equal to the distance between two bright fringes multiplied by d divided by L. And we'll just plug in the values given to us in the problem. We're told that the distance between the bright fringes are 1.58 centimeters. So converting that into meters, that's 1.58 times 10 to the negative 2 meters, multiplied by d, the slit separation, which is given as 0.2 millimeters. So 0.2 times 10 to the power of negative 3 meters, divided by L, which is given to us as 5 meters. If we put this into a calculator, then we find a wavelength of about 6.32 times 10 to the power of negative 7 meters, which can also be written as 632 nanometers. And that's the answer to this problem. I hope this video helped you out. If it did, please consider subscribing, as it'll help me out in making more videos like this. And if you have a question, leave a comment down below, and I'll do my best to help you out as best as I can. If you have a request for a future video, or you just like to hang out, my Discord server and my Twitch page are both linked in the description, so check those out if you'd like. But that's all for now, and I hope you all have a lovely day. Bye-bye.